Now let's just see the next question. Question number 2 says that ABCD is a rectangle. PQRS are the midpoints of the sides AB, BC, CD and DA respectively. Show that the quadrilateral PQRS is nothing but a rhombus. So we have to show that it is nothing but a rhombus. So let us suppose if I'm just forming up a rectangle over here. So this is nothing but my rectangle. So further it is A, B, C and D. Further it says that we have PQRS being the midpoints. So let us suppose if I'm just taking the midpoints as nothing but PQRS in the manner, this is P, this is Q, this is R and this is S. I'm just taking, and let us suppose if I'm just joining them as this. Okay, so we have to show that PQRS is a rhombus. We have to show that it is nothing but a rhombus. PQRS is nothing but a quadrilateral. PQRS is nothing but a rhombus. We just have to show this particular fact. So first of all, let us suppose if I'm just doing a little bit of construction over here. What is that construction? Join AC. Join AC. So I'm just joining A and C. Now furthermore, if I'm just joining A and C, then what are we getting from this particular AC? Since we know that in the triangle DAC, S and R are the midpoints of the sides DA and DC, it implies that SR is parallel to AC and SR is nothing but a half of AC. By the midpoint theorem, the line segment joining the midpoints, of two sides of a triangle is parallel to the third side and also half of it. So using that concept, we can say that SR is nothing but half of AC. Moreover, in the same way, we can say that, let us suppose if I'm just calling it as nothing but the equation number 1. Again, we can say that in the triangle BAC, P, Q being the midpoints of the sides AB and BC, implies that PQ is parallel to AC and PQ is half of AC. Let us suppose if I am calling it as 2 by midpoint theorem, I am just writing by midpoint theorem because it is nothing but the same explanation that we have given over here by the midpoint theorem. So what can we say from 1 and 2? So from 1 and 2 we can say that SR is nothing but is equal to half of AC, which is nothing but is equal to PQ, which implies SR is nothing but is equal to PQ. Means what we are getting over here, that SR is nothing but is equal to PQ. Now we know that SR is nothing but a side which is coming out to be equal to PQ, and furthermore we can say that SR is nothing but parallel to AC and which is also parallel to PQ. So it implies that SR is coming parallel to PQ. SR is also coming parallel to PQ. So hence at the end, what can we say? We can say that we already have deducted that SR is parallel to PQ and SR is equal to PQ, which implies that one pair of side is parallel and equal of the quadrilateral PQRS. It implies PQRS is a parallelogram. It is nothing but a parallelogram because one pair of opposite side is actually nothing but parallel and equal. So hence it is definitely nothing but a parallelogram. So if it is a parallelogram, then it is also implies that PS is also is equal to RQ. It implies that PS is also is equal to RQ because the opposite sides are equal. Opposite sides are equal. Now we just only have to prove this fact that PS is actually is equal to PQ. So for this I'm just taking the two triangles. So in triangle, let's just start with in triangle PAS and triangle PBQ. I'm just taking two triangle PAS and PBQ. So what can we say about these two triangles? First of all, angle A is equal to angle B, each 90 degree, because we know that in a square in a rectangle we have these two angles as nothing but 90 degree. So this is also 90, this is also 90. Furthermore, we know that AP is nothing but is equal to PB, since P is the midpoint. It is the midpoint. Further we know that SA is nothing but is equal to, SA is nothing but is equal to QB. SA is nothing but is equal to QB. Can we say about this fact that SA is nothing but is equal to QB? Yes, we can say that this SA is nothing but QB is equal to QB, since S and Q are the midpoints. They are the midpoints of DA and BC, and we know that DA is nothing but is equal to BC because it is nothing but a rectangle. So in a rectangle we have this side is actually is equal to this side. So if S and R are the midpoint, so it means that this side is also equal to this side. So hence it implies that SA is also is equal to QB. So what can we say from these? We can say that hence these two triangles are actually nothing but congruent to each other by SAS congruence criteria. You can see over here that by SAS, this is the side, this is the angle, this is the side. So by SAS they are congruent to each other. If they are congruent to each other, it implies that PS is nothing but is equal to PQ. PS is nothing but is equal to PQ by SAS criteria. So hence at the end what we have deducted, from this, that is RS or SR is equal to PQ. So from this, let us suppose if I'm calling it as star, I'm calling it as nothing but double star, and further I am just taking it as nothing but a triple star. So what can we say from these three equations? That SR is nothing but is equal to PQ. It is nothing but is equal to PQ, and we have PQ is nothing but is equal to PS, and PS is nothing but is equal to RQ from the equation star, double star and triple star. So we can say this particular fact from this, which implies that all the sides are coming equal to each other, and hence PQRS is a rhombus that we are getting. So this is nothing but a rhombus because in this we have all the sides are coming equal to each other. So this is nothing but the rhombus. So hence this is nothing but the proof of the question number 2.